Well, I'm just a little bit perturbed today. I don't usually get agitated and get on a soapbox and complain about things, but I know a lot of you guys, you're my regular viewers, deal with mechanical things every day, and you might feel the same way. I've got one little lathe over there in the corner, my little South Bend, that I have an electric motor on. Just simply because sometimes when I don't have the boiler steamed up, I need to do make some little bushing or drill a hole or something like that. And well, the other day had the piping all apart, and I was running lines to this new engine and I needed to do a little job for a customer, and I was just finishing up the last part of it, and whammo, the motor, smoke, fire, that's all there was to it. So the job didn't get finished, and here's the motor. Now, I know this motor can't be over 80 years old, and I think electric motors are a very clever invention, but they're going to have to do something about the reliability of these things if they're going to catch on. Hi, and welcome back to another issue of Old Steam Power Machine Shop. It's been a pretty busy couple weeks here, and I got the big engine tuned up and tightened up, running pretty good, pretty happy with it. In this episode, we're going to try to finish up the blocks on the counter shaft for the hacksaw, and pour the Babbitt and bore it. And one thing I want to talk about, I've had a few viewers ask me where they can find information on all this old stuff, machine work and steam engines and belt drives and things like that. And I'll tell you, it's out there. Nothing has changed. It's still around. You can go on eBay and find a wealth of books that don't go for much money because most people don't know what they're looking at. And I've got quite a collection, and I'll just show you briefly a few of them. You know, these books were printed at a time when there was a little bit of a different work ethic in the country. I mean, people had jobs, young men were farmers, and they're trying to move away from the farming work, and they were taking responsibility to equip themselves for the job that they had, or educate themselves for a better job. And they did it usually on their own time, with their own money, and there was a lot of book printers that catered to that. A couple are Hawkins, Audell's, and International Textbook Company in Scranton, Pennsylvania just printed thousands of these small books about every mechanical subject you could think of. And this particular one is Lathe Work, Book 1, and it's got in it, of course this particular one is copyright 1926. So we're talking old machinery like what we're using here. And it's got how the machines are made, how to set them up, how to grind the tools, what the shape of the cutting edge should be, bench work in there on filing and chiseling, even how to make reamers and cutters, which they did a lot in the shops. And these are all numbered, and it would be just an incredible huge set if you had the whole set. I've got several of these. This is this is a pretty neat thing. This is Machine Tool Operation Part 1, copyright 1919, and it was evidently used in an apprentice program because I've got all the handwritten notes from the student here, and there's a lot of stuff underlined and notes in the margin, and this is a pretty good general information book. Here's a Audell's Engineer's Mechanics Guide 1, and this is basically stationary steam engines, how they're constructed, how to repair them, how to maintain them, how to set them up and adjust them. Everything there is probably you know about a slide valve and its shape and its design. Reverse gearing, all the different types of reverse gearing for steam engines, and that's a good one. Here's another one, Practical Stationary Engineering. This is copyright 1909, and the illustrations are just amazing when you stop to think that these aren't really even photographs, they're etchings. The amount of work it took to make the etchings to illustrate the thing. And a lot of them, like the Audell's and the Internationals, have questions in the back of them, and I'm not sure if the answers are there, but you could write to them to get the answers in the old days, and they would issue you some type of a diploma or certificate. Here's a Hawkins, they're also very good. This is Aids to Engineers Examinations, and this is the book that would prep you if you were going to get a job in a boiler room or around an engine in a factory. And it's got all the testing about steam engine indicators, how to fire the boiler, how not to fire the boiler, what to look for when something's going wrong, what to do when something's going wrong. There's and I just love these Carpenter's books too, because this is really lost stuff. How to lay out framing using the scales on a real framing square. It's got all kinds of scales on it, and I never really knew how to use them or what they were for until I started looking in this book. And I mean, if you have to lay out a octagon pyramid roof rafter setup, this will show you how to do it. And I don't think there's many carpenters out in the field working that would even know where to begin to figure this stuff out. And it's all in this book, because back in the Victorian age, that kind of architecture was really popular. This is probably the main book for steam engines. It's called The New Catechism of Steam Engines. And this thing was printed, oh man, a lot of times. This particular one was given to me by a viewer, and it's 1901, and I like it because it's the oldest one I've got. But it basically is just an overview of steam engines and what steam engines were available at the time and what made this one different from that one, and it's got some in here about locomotives and just kind of an overview. A very good reference book. And then this is one volume out of a 2-volume set that I've got, and this is the mother lode right here. It's called Modern Machine Shop Practice, and there's several books that were printed with a similar name, but this one is by Joshua Rose, and this particular one is copyright 1914. And between these two books, there's probably everything that was going on mechanically in that day and age. It's got all the machine tools in here and how to set them up, how to run them, how to grind tool bits. There's a whole section on just chisels points, how to grind them and how to use them. Then it gets into steam engines, their design, slide valve design, valve timing, automatic engine cutoffs, indicators, and that's just in this book. The other book is more shop related. It's got everything there is to know about flat belt drives and pulleys and stuff like that. And somebody asked me about this book, and I went on eBay the other night, and there's a 2-volume set in better shape than this for sale on eBay right now, and I think they want like $50 for it. So anyway, that's the literature side of the thing. So we'll get to work. We're in the process now of pouring the Babbitt liner in the bearing blocks for the counter shaft for the hacksaw. Thanks for all your comments and all the subscriptions and all the emails that you send me. I read every one of them, and I try to answer them, and I appreciate your support for this channel. Thanks a lot. I know I covered this before on some of my earlier videos, but I'll show you how to lace a belt up with these clipper belt lacings. This is the U4 size for the thicker belts, and I like this one, this particular style, because it's got the extra wire spot welded in it to hold it together while you're working with it. So I'm not going to have to go by the belt. I'm going to cut this so that it makes just enough hooks to cover the end. That's it right there. So you push it down in there, and they give you this nifty little thing here to slide in there. Okay, this side goes against the belt, this side goes against this outside. So I put the little extra wire on the outside. Get this in here. My eye as close as you can get it. This belt is a lot tougher and harder than any of the 100-year-old stuff I've been working with in this shop. Doesn't quite drive it all the way down. Pretty close, but finish it up with a hammer. It is. It turned out to be about 25 feet long. And first thing I'm going to do is oil it up with neat's foot oil, and it soaks it right in like a sponge. And you can see, although I left about 1.5 inches short from what I measured, it's stretched and it'll continue to stretch. I'm probably going to have to cut this lace out and relace it and shorten it up 3 or 4 times at least. Okay, we're set up to go. Speeded up the governor by putting a pulley on here that's twice as big. It's a wooden pulley and sort of an experimental deal. It worked out really well, so I've got a cast iron pulley that I'm going to cut down and fit. I was really surprised that the valve in this governor would hold the engine back to 100 RPM at full steam. It's a very tight valve in here. We got lots of steam, blow the water out of the pipe. Give the lubricator a couple of twirls. And I got the first job under this engine's power set up in the drill press. This is the bearing for the new countershaft for the hacksaw. And I'm boring or drilling some 11/16 holes here, tap half-inch national pipe, put some half-inch pipe knuckles in there for oil holes. I'm going to show you how it starts up. It almost never stops on center. It just takes just the slightest little bit of turn with the throttle. You will hear the slide valve kind of snap up against the ports, and it takes right off. And I can turn the throttle valve all the way open because the governor is in control of it now. Boy, it's quiet. I don't know if you'd be able to see this. Maybe I'll take the camera off. Every once in a while, a little drop of oil squirts out of that pipe. That's the feed rate for the oil pump. And that runs up here. There's this copper tube here. And out this side and up into the steam line right there. I'm getting ready to pour the Babbitt liner in this bearing housing. These are the oil spouts that I screwed in there, pipe threaded. And all I did here was I made up a couple blocks of wood that fit fairly tight on the end that have a hole concentric in the center. And this is a mandrel made out of a piece of galvanized pipe that was about the right diameter. And this is almost 1.400. I'm gonna end up 1.5 inches. So that leaves me plenty to bore out. So that will fit up in there. And this will fit up in here and hold everything square. I got to put a little Babbitt Wright putty in the end here in case some would want to leak out between the metal and the wood. I don't think it will, but I don't know what's going to happen to this wood when I start heating this up with a torch. I tried to label it. This was some good Babbitt that I melted out of something. I forget what. This one is marked unknown Babbitt, which is the same deal. This is some good stuff that I got from McMaster Carr that was left over from another job. And this this is some railroad Babbitt that came out of a Babbitt bearing rail car, old style. And I know it's got a lot of lead in it because the railroad was pretty cheap with their Babbitt. It's not as good a grade, but for this job, it's not as critical as it would be, like say in a rod bearing for an engine or something. Runs pretty slow and pretty low load, so I may mix some of this in, cut it to make it go a little further. So I got the hot plate going over here, and we're heating it up, and when that gets melted, I'll bring you back. Never seized. Works pretty good for me. Babbitt, hot. I'll give this just a little bit more preheat. I mean, it's not super critical, because if it doesn't turn out the way you like it, you can always just heat it up and melt it out and do it again. It's not like welding something. You sort of have to live with it or grind it out. That ought to do it. It's running out of somewhere. Oh, it's pouring out. Yeah. Alright, this is a much better setup. I got it set up vertically and turned up some little wooden tapered plugs to drive in the oil holes here. They don't go all the way in, so some of the Babbitt will go out into the oil hole cavity a little bit and it'll lock it in place. Really nice. And I've just got this kind of centered up by eyeball on top. How did it do that?
Very nice. That turned out pretty good. Let's see, we'll push it out from this side in the press. Okay, I pressed the mandrel out in the hydraulic press. It didn't come out too hard, and that's what it looks like. That the top had some inclusions in here, probably from gas bubbles or something. I thought I would have more trouble with the bottom because I started to pour it and then I stopped and started again, but that's good and solid there. But this is going to get bored out quite a little bit, and most of that will probably be bore out, and the rest I'm not too concerned with. Then when I get all done, I'll drill the oil holes back out. And there's that one. I got one more. Okay, we're ready to try the second one. I think one mistake I made on the last one was I just had the thing too doggone hot. Every time I've had problems with a Babbitt having bad spots in it, it's been because I've heated the housing too much. So I've got it, I don't know how hot, but not as hot as I had it last time. Whoop, wait a minute. I got to put the plugs in there. Let's see what it does. No leaks. Now that one came out almost perfect. This is the first thing I've done on the lathe with the big engine running the line jet. And it's just amazing how quiet it is. All you can hear is the belt waves when they hit the pulleys. A little click or a little rattle now and then when the belt rubs against the shift wheel. It's take a little getting used to. Hear all the gears and the waves. Hear the tool. Hear the cut. Last pass. Take off about 8 pounds. Slow it down a little bit. Give it a shot of turpentine.